Hello, everyone. Welcome to another episode of Quirkcast. This is your host, Tim.
And I'm Mikey.
This is Sahil. Welcome everybody to a brand new exciting episode of Quirkcast. If you're on YouTube, please do post any questions or comments during the episode so we can get to them. And if you haven't already, more guilt tripping, join our Discord channel so you can match with us there too. So getting to this episode, so Mikey, I was practicing a lot of gratitude, and I told one of my friends that I'm glad they exist in this world. And then I wonder, like, based on the topic of this episode, like, what does it mean to exist? So was I giving a genuine compliment, or like, is existence like fake?
I think that's the highest compliment. I mean, I think like thanking someone for their existence means thanking them for their relative existence with respect to you, right? And I don't know. I'm advocating I don't know, perhaps a little new agey view that like things only really exist to you with respect to their interactions to you. Tim apparently believes in some notion of absolute existence, which is go ahead.
I'm not sure I believe in any particular notion of existence, but I think it's fair to bring up one of the age-old question, right? Like there's one of these philosophy debate questions, like if a tree falls in a forest and no one is there to hear it, did the tree make a sound? And to some extent, to a physicist, it sounds like almost like a silly question, because sure, even though nobody's there to hear it, like clearly it interacted with the molecules, and the molecules vibrate, and you can define sort of literally that's what sound waves are. Sound waves are just air molecules jiggling around. And so by that definition, it seems obvious that the tree has made a sound. But I think it gets a little trickier if you go deeper.
Physicists mean something different, right? Physicists mean if the tree falls and there's no way you could even in principle hear the sound, then did it really fall?
Oh, okay, yeah. So I suppose there's two parts in this. First, like, can you actually, in principle, even measure something? Like that's kind of like a one type of requirement on what it means to exist. And the second part is, even if you can measure it, like what does that measurement mean? Like what does it mean to measure something and that thing existing? Like is that enough? So
wait. Let me break this out into two different. I think that's what you mean is like, is it possible to measure anything, like full stop, right? And then if it's possible to measure that thing, is it possible for me to measure it? Those are two different.
I think that's fair. Yeah.
Okay, continue.
Yeah. So I don't know. Well, which part should we discuss first? I suppose.
I don't know. I think you're more interested in the topic of whether or not it's possible to measure anything, period. I think I'm interested in the question of whether or not it's possible for me to measure. Like what are the things that are possible for me to measure versus the things that aren't possible for me to measure based on where I'm standing right now.
I guess we can start first with like, what does it mean to measure? Whether something's like measurable or not, and then dig deeper in that. Because if nobody can measure it, then it's like, it's not measurable. So then we don't have to worry about it.
But what can't we measure, Tim?
What can we not measure?
What can't we measure?
What can't we measure? I guess that's a little hard to answer. Maybe it's easier to just say what we can measure. I mean, what we can measure are some level of interactions, and I think it's quite fair to use the analogy of sound waves. Ultimately, at the end of the day, all the particles that we see are just kind of like different sorts of fields jiggling. So that you can think of them as some abstract sorts of sound waves. We're like listening to sounds of different what we call quantum fields in the world.
Well, it's interactions jiggling. That's why it's
right.
Sound, right? Yeah, it always involves compressing or decompressing.
Right. Yeah. So basically, I guess the most basic thing we can measure is one thing jiggling, different types of things jiggling. Like when I see something, it's the electromagnetic radiation, electromagnetic field that are jiggling, goes into my eyes, and then the brain signal, electrical signal. and register. Like I'm an instrument. So and I can see that, but I think that notion is a bit vague, right? Like we always seem to have this clear notion of, oh, like Sahil, you're there. Like, come on, how can you not be there? But is it really though? Like sure, maybe it's 99.99999, how many nines they are percent correct, but there's still this tiny lingering bit of a doubt that like, what if this interaction of you, Sahil, your image coming into my brain may not be what I'm thinking it really is, if that makes sense, because of the quantum nature of the world, that everything is not absolutely certain the way it is. So in that sense, I think what we can measure is like, you can definitely measure something there, but what that something is a bit ambiguous, I think.
But it's not in practice, right? Like it's true that like, from first principles, it should be ambiguous. But we have classical protocols. You and Sahil can meet up later and do a handshake and agree that what you discussed before was really what you discussed, and you can verify that. And all the experiments that have been done so far indicate that reliable communication is, a reasonable thing.
Huh. So are you saying what's measurable is something that you can like observe and coordinate on? Is that a good definition of something that's measurable?
I would say, so wait, Tim, are you getting at the fact that like that things can't, like observables are not precise enough to be measured exactly, and that's why we can't?
Yeah, I think this brings back to some of the topic that we talked about in previous episode. For example, the location of Sahil can only be approximately pinned down to some place in this universe, right? That location, even in principle, cannot be 100% accurate. So with that in mind, it to some extent it means that there's this question like, does an actual location exist beyond this approximate notion of Sahil's location, right? Even though we can kind of measure it, right? And it goes beyond that, right? Even the identity of Sahil, like Sahil is basically a collection of particles, electrons, protons, whatever, right? But do we really know what those particles are? Like I know in everyday life, it's like 99.99% there, right? Like if you give me a proton and I shoot a beam of light on it, I measure it and be like, it seems like every measurement says it's a proton. But is it really though? Like in particle physics, like you can the identity of a proton is what we really say, sort of like a low energy approximation. It looks like a proton and it cracks like a proton if you shoot beams of light that are low energy. At some point, you shoot beams of light that are so high energy, you're going to destroy the proton. And once you destroy the proton, it's not even obvious if you had a proton to begin with, because you've changed the system. So the question is, if you can't pin down, if you cannot pin down a proton's existence 100%, and then it doesn't, then you can just kind of go forward, right? Sahil is made of protons and it's made of electrons. And none of those particles are absolutely 100% can be pinned down, like, then there's some notion that maybe Sahil doesn't exist to some extent.
Is that a problem for me philosophically though? Because we can agree on the fact that something like a proton that made up something that's like Sahil existed in a place that was within this ball, and that's good enough for most people, right? Like I don't know why this is a philosophical conundrum.
And I just see myself as a compelling story. That's it.
Well, imagine this. Like I hate to use this word, but imagine there's a God, okay? Like I hate to use this word God, but just imagine someone's controlling the universe and just seeing like there is Sahil, right? But then imagine this system that this God being is controlling. Like instead of having just Sahil here, you just have to have this fuzzy notion of Sahil being there, right? And it depends on however you are measuring Sahil. So then it makes the God's job really difficult. Basically, what I'm saying is, Like it's not like
we measure Sahil mostly the same way each time, and there's like a there's like a lot of time-wise correlations in the way we talk to him and get verified in the fact that
I would say Sahil is mostly consistent based on the human scale of interaction, like within let's say, I don't know, minutes, hours, and within the energy range of the instrument we use, like light particles that are not very energetic. At the moment we wait, let's say eons. Well, I mean, Sahil can't live that long, but if we mummify him, if we wait eons, like protons could decay. And then, if we use energies of light that are so strong, gamma radiation could just completely destroy Sahil's being, then that's a different story. So I guess I could agree with you that there's a range of instrumentation that could yield a consistent story of Sahil, but it just isn't absolute.
Yeah, but all experimentation thus far has revealed a Sahil that's fairly consistent in its existence.
Well, but it's a human. I mean, my problem is that it's a human-centric experimentation. Like if I was a being of God, I would do like I would blast out here with some majorly energetic photons. Sorry.
No, but my point is, I think the human-centric one is the only natural one, right? Like, I think the laws of physics teach us that you have to be a little bit egocentric, and you can't subscribe to this idea that there's this independent existence of this universe that at least exists in all places or all patches of space-time simultaneously, right?
I think, yeah.
Oh, could we, for the audience, go into this discussion about position not being well-defined, or these like position time, or these things in, I don't know, in the context of what you're talking about, but not being well-defined in general?
I think I have a feeling that what Tim is basically arguing is that you can't measure things exactly with 100% precision, so you can't be guaranteed to exist, that what you're observing from one time to another is actually the same thing, or whether it's just a new iteration of Boltzmann brains.
No, I wouldn't go as far as that. I would say that because well, I mean, there's this theme in physics, right? If you cannot, in principle, pin down something, or even get as close as possible to something, then that something, maybe doesn't exist, right?
I thought it was. Is it about how does it have to do with precision? About how closely you can pin it down? I thought it was.
No, I think that's fair. Like even in principle, even in principle, an object cannot just be measured with as much precision as possible. Then that idea might just be an approximate idea. I think that's fair.
Is it? I feel like it's about whether or not you can measure with any degree of precision. Okay, so maybe just to update the audience on what we're talking about, like the classic example, right, of things you could never observe. Let's say things that are outside of this universe, right? They're just so far that, like, even if you traveled in one direction as far as you could for so much time, like your particles would dissolve before you got there. So there's no way, even according to any laws of physics, that you could ever observe these things. They're completely separate from you. Do those things exist? And that has to do with the fact that we're separated from them. We can never communicate with them. So, for all intents and purposes, they might not exist in our reality. These events that are so far away that we could never affect them. It doesn't have to do necessarily with the precision that we can measure them with, does it?
Yeah, I think that's a separate story. They might be related, but that's a separate story.
Oh, they are related, I guess. Yeah, because distance equals precision.
well, everything to some extent is related. I mean, to some extent, I have to concede that, like, observables that we are interested in are obviously observables that we humans can observe, right? Like, I mean, by that, that there's no way around it. But it just makes me very uncomfortable because we're scientists, physicists. We try to have this external reality hypothesis, right? We assume that there's a world independent of humans that is real, that is measurable, even if humans were not there, right? But But then to some extent, we find that observables are ultimately approximate. So it's like, well,
I think relative is the key, right?
But why not both?
Oh, no, it's both. It's both. Yeah, it's definitely both. But the approximate part, I don't have an idea for what the solution to that is, but it's okay. I can still sleep at night because even if it's only approximate, like my experience has kind of confirmed the fact that things like locations do exist, and that a person that is in the same location for a continuous amount of time is the same person. Like I can kind of like bootstrap my logic to accommodate that. The notion of like precision, but I think like when we think about things that we can never interact with, like things that are so far away that we can never interact with them, like do they really belong as a part of our reality? Or things that happen so quickly that we could never observe their effects. It's actually two sides of the same coin, but do those kinds of things that happen, do they deserve to be considered part of our reality? I think you could argue yes or no, but the interesting thing is that a lot of recent developments in physics have indicated that if you insist on considering them part of your reality, then you will be led to paradoxes. Most famously, the fact that like the interior of the black hole is a place that you can never even access or communicate with in principle while staying outside of it. If you insist that the black hole is evolving according to the same laws of physics that you're familiar with, it leads to literal paradoxes. And I think this is evidence for the fact that if you can in principle interact with something, that they don't exist in your reality.
Yeah, I think that's a fair point, but I want to kind of throw some difficulties with some of these discussions because I think in the case of poles, well, black holes are murky enough already, but in the case of expanding universe, you actually don't know fully if you can actually reach something or not, because it like imagine you have some toy universe.
Oh, you almost certainly can't. Yeah, if there's certainly places you'll never reach.
Right. No, but that actually depends on the future trajectory of the expansion parameter, because like it's plausible that a universe that's expanding rapidly maybe at some point could slow down again and do a big crunch. Like imagine some weird toy universe, right? So it could be in one instance, you think that there's certain objects. Let's imagine Sahil. Well, it's always you, Sahil. I apologize. Like you just blast off to Andromeda or somewhere, okay? And at some point, the universe is expanding so quickly, Sahil would just like I do some calculations, like, oh man, I'm never gonna see Sahil. Like even doesn't matter how I try, because it's expanding so much that I'm never gonna reach him, even if I drop the speed of light. But then lo and behold, maybe some eons later, somehow we're still alive, right? And I look at the expansion rate of the universe. Hey, it's actually going back down. It's actually doing a big crunch. Then I start thinking, hey, like, if Sahil really want to meet up with me again, maybe he'll turn around and kind of, as the universe is shrinking down, maybe we'll actually meet up again. And the question is, like, in the meantime, does Sahil exist or not? Like, at some point, he's kind of like totally out. But like, the universe shrank, like, to some extent, but Sahil was back into the game. It's like, well, that's a little odd, right? Like how, like does existence depend on just like knowledge of what's gonna happen in the future or no?
I would say that's like existence is context dependent. That would be my answer to that.
Context implies interactions between neighboring points, right? Which is essential, I would say, an essential ingredient to reality.
Yeah, if that is what that implies, then yes, then yes, I agree with that. So I guess, Tim, I kind of want to dig a little bit deeper into like why, like, what do we do if things are not like observable? Like, what does that mean? Like, what does that mean for us? The limit of mathematics, or is that a limit of like us? Is the limit of nature, or what would you say?
Oh man, I think that's
But
like
wait, let's talk about which notion of observability. You're talking about they're not observable. They're not observable because they're too far separated from us, or they're not observable because of some fundamental limitations on observability.
The thing that things that are observable are relative. So like when you talk about like quantum gravity, it's hard to describe it relative to what, or at least Tim, that's what I remember you mentioning.
Okay, yeah, I'm on board now.
wait, sorry. What's the question again? That this gets so complicated.
So the question is like you mentioned things aren't observable. So if they're not observable, then what do we do about that? Like what does that mean?
What do we do about that?
Yeah.
Well,
The question is, do we have the right to try to describe them? Right. If things are not observable in principle, do we have the right to try to describe them in our language?
I mean, in terms of everyday lives, you can argue that it doesn't matter very much. Like all this notion about things imprecise, things that are beyond that we cannot in principle observe, doesn't like our discussion doesn't affect our everyday lives, right? Like Sahil, you're there. Like I know you're there because probably I'm not gonna see a gamma ray blasting into you and just disappear. Like that doesn't happen. So you exist as far as everyday lives is concerned. You know, it's a good concept, right? Like,
assume that Sahil exists, right?
Yeah, that's a fair concept, and it's almost insane to think that it just wouldn't make sense to have this such a nihilistic point of view, to think that, oh, maybe we're just in some silly simulation, everything is just
brains just
yeah everything's like a facade of something. Like that's silly, right? Like I think it's fair to say that there's
that keeps me up at night.
yeah, it's almost like there's something definitely is there. Like Sahil, you're there. Something about Sahil is there. But whether that's really Sahil or not, then we have to go down the rabbit hole. But Sahil as a concept approximately is there. So maybe it's good enough.
Part of our existence. And I think the example you gave is interesting because it indicates how Sahil could pop in and out of our reality, right? Like depending on how we define it.
Yeah, maybe to some extent, we just kind of have to give up this idea of an absolute existence. Once again, maybe that's just too human of a notion. It's like a kid.
I think we have to. I think the recent results with black holes indicate that we have to give up this notion. If you can't describe things, yeah. I think that the lesson from recent studies with black holes, theoretically, is that you can only describe things using Newton laws in your coordinate system if it's possible in principle to observe those things. So that everything inside of a black hole is off limits. Everything outside the observable Hubble volume is off limits. Everything outside of the light cone is off limits. So it shrinks our reality down to a very kind of narrow chain of events. But luckily, we all live very close to each other. We all live on the planet Earth, so we can all kind of share those experiences. But from a galactic or even a galactic standpoint, there's no sense in which we exist in the same reality, I think.
So one thing I wanted to get your thoughts on is like I guess like these sort of like the use of language to describe things like concepts or like emotions that you feel or you discern that you feel, and like does that exist in a certain way? Like it is interacting, you do feel it, but it's just exists within yourself. Like no one can really understand like how are you actually feeling. Yeah,
the configuration space of an individual, that's something that you interact with most, right? Because you're interacting with your brain the most.
Yep.
And anyone who interacts with your brain through less conducive channels it's like a game of telephone, I guess.
I mean, I think though that sort of question is kind of going to the different direction. We're talking about like emergent behavior. I think so far what we've been discussing so far is sort of like the fundamental kind of reductionist way of viewing about things. Like if I break down Sahil in tiny particles, I say for sure that each particle exists and with certain properties, and the answer to that is, not exactly, but maybe 99.99999% good enough, right? But now you talk about things like emotion. This is more like, it's more like a collection of many, many particles interacting, and then some pattern, combining together forms some notion of, I guess, emotion in Sahil. Whether you express that or not, I think if you define that as the collective, configuration of your particles, I think that's fair to say that exists, but within the limit of, emergent phenomenon, basically.
Oh yeah, you could consider emotional expression to be one of the most complicated forms of interaction, right? Just in terms of particles, in terms of like how particle states are affecting other particle states.
Yeah, and I think it's almost like how sound waves and water waves exist. You can say, hey, a water wave is taking over, the beach. It's a rolling motion of water molecules, right? But if you really zoom into the individual molecules, you're like, wait, where's the wave? It's just like, molecules jiggling around. Only when you zoom out, you look at the overall pattern of these molecules moving together. You say, hey, there's some sort of this wave that exists. But then the existence is not absolute, right? To what extent do we say it's a wave versus just molecules moving around, right? It's not absolute, So I would say I think the existence of things like this, I think that it's a good approximation, I think, but definitely has its limits.
I don't know if it's more than an approximation. It's almost like the canonical example, right? Because when you express a very complicated emotion to someone, right, that could induce a very complicated like state interaction, right? Like the state of my brain versus the state of your brain. Whereas if I express a very simple emotional interaction, it's a cartoon, but you can imagine like, oh, I don't like that guy. Okay, I don't like that guy. It's like you can almost project it to a binary space, right? So in that sense, I feel like you can almost argue that the more emotional of a communication something is, the more of an interaction it is, and the more that the object you're interacting with now exists in your reality. Because if you're saying that, yeah, the complexity of interactions dictates what's part of your reality or not, then that's like the highest form, right?
This reminds me of a quote from Dirac. It was like, the goal of science is to take complicated things and simplify them down. Poetry is the exact opposite.
Wait, what was the last part?
Poetry is the exact opposite.
Yeah. That's a weird inverse version of what I'm imagining. Yeah. As humans, we crave things like poetry, I assume, because we understand at some fundamental level that the more complex of the interaction that occurs between us, the closer the connection.
Yeah, I sort of see it like the sciences that I've learned have been very reductionist, and the humanities is more of like integration of things together, like integration of building blocks together.
You didn't study condensed matters.
That's true. That's true. I did not study condensed matter, although, yeah, I have.
No, but I think this is an interesting point, because when you talk about things like waves and emotions, this all seems like very emergent phenomenon, and it seems like all the notions of those things existing is very approximate. But of course, you look back to particle physics, you can't help but think that maybe a particle is also emergent. Maybe a particle is a wave of something else, and maybe the fact that we cannot pin down a particle, just like we mentioned, because whether a particle exists or not seems approximate, that's very analogous to how waves are kind of, the existence of waves are kind of fuzzy, like whether there's a wave. So
also it can relate to how difficult it is to pin down emotions. I think so.
I would agree with that. So we're basically at time, and I want to give you guys what would your concluding statements be of where you stand on existence? And do they exist is the other question.
I think I don't know. I used to not like have an opinion on this, but I think there's, yeah, I think, you know, if it's old age or if it's a selective reading of physics papers, but this like kind of new agey idea that things only exist relative to us. I don't know. I think it's becoming more appealing to me. There's a lot of evidence that parts of the universe that are not accessible to you in principle are actually distinct parts, and you can't even use the same physics to describe them. And to me, I think it just adds weight to the idea that my reality is defined by the interactions, and yeah, kind of a relationship-based view of existence.
Yeah, I would say that for me, for me, sort of this viewpoint of reductionism versus emergence is important. It seems the deeper you dig into many of the so-called observables, things we can measure, like energy, position, and all that, the more you look into it and how they're all approximate, the more you see that they're very similar to how emergent phenomenons are approximate, and ultimately these emergent phenomenons, I guess in a reductionist kind of way, break down and reveal something more. And it seems like probably some of these concepts that we have, you know, particles and whatnot, are emergent still, and maybe something else will come up again once you dig deeper, or maybe this never ends. Basically, it's turtles all the way. It's possible. Then I don't know. To some extent, I'm not sure what it means. You know, when the more layers you have of this kind of peeling off of emergent phenomenon, the more you kind of ask the question, you know, what does it mean for something to be there? I don't know. It's I guess I'm confused, I think.
I am as well. Confusing existence, but it is very exciting. I'm going to take a stab, you know, at summarizing what I've learned through this episode. I would say that existence, there are simply just useful constructs that persist in memory that come up, because there's nothing else but constructs. And it just so happens that we've come up with a language that's countable as an approximation to being able to describe these constructs from one human being to another and coordinate. We sufficiently agree that these things exist because they're simply useful. And if they don't continue to exist, that means they're not useful. And that's just kind of the way I sort of see it.
Can I just add one thing to that?
Yes.
The important point is that, like, there are multiple ways of doing what you just said, and that entities who are separated from you in terms of interaction, even in principle, could be described by a completely separate set of rules, and not subject to, you know, the same coordinate system that we use to talk about our relative relationships.
Are you saying that implies that, or?
Just no, that is like we have like a kind of a rules-based system for describing physics based on our relative interactions with each other and the relative similarity between our coordinate systems, which allows us to kind of speak the same language. And for parts of the universe that are not observable to us, they are not subject to these same rules or these same laws of physics, as we would call them. And there's evidence that they can't be described by them, which is...
Yeah, so Star Wars may not make sense. Sorry to burst your bubble.
Yeah.
There is no intergalactic war.
It's so hard to make that connection. Let's save that for a later episode. It's crushed me. Maybe that's that.
Yeah, Then, so with that, I'd like to thank everybody for joining us, and we'll see you all next week.
See you
Yeah.
guys. Bye.